My name is Nutifafa Adotey. I am the University of Tennessee Soil and Nutrient Management Extension Specialist located in Jackson, Tennessee. Today, Dr. Saha and myself will be talking about the nitrogen loss from cornfields, from surface applied nitrogen fertilizers, and a tool that is available to minimize this type of nitrogen loss. Nitrogen is very important because it drives our yield. And for most corn production budget, it constitutes somewhere between more than 10% of the production budget. Given this substantial investment, it is very critical to implement best management practices to be profitable. Also, inappropriate nitrogen fertilizer application can also contribute to the ever-expanding dead zone in the Gulf, which can influence marine life. So in Tennessee, one of the management practices to minimize nitrogen loss is to split apply that nitrogen fertilizer. In Tennessee, most corn growers split apply a third of the recommended nitrogen fertilizer at planting and side dress the remaining nitrogen between the V4 to V6 growth stage, which is closer to the period where the plant is actively taking up that nitrogen, the V8 to V10 growth stage. So split application of nitrogen optimizes that nitrogen uptake by the plant. However, there is still nitrogen loss, and the extent to which the extent depends on management practices, environmental conditions, as well as soil properties. One of the management practices that can influence the side dress nitrogen loss is the type or the nitrogen source. There are several sources, but in Tennessee, urea and urea-based nitrogen fertilizers are commonly used because they are cheaper, they are safe, and they have limited logistical constraints. However, these nitrogen sources are also susceptible to ammonia volatilization, which is one of the nitrogen loss pathways. So before we get to the nitrogen loss pathways, plants can only take up nitrogen in two forms, either as nitrate or ammonium. They may take a little bit of that urea, but nitrate and ammonium are the two major forms the plant takes up nitrogen. So when your urea is applied to the soil under favorable moisture and temperature condition, the urease enzyme breaks that urea into ammonium, and then it further oxidizes to nitrate. So there are three dominant ways your surface applied nitrogen can be lost in the field. We have ammonia volatilization, we have leaching, and we have denitrification. Ammonia volatilization occurs when your urea or your UAN is sitting on the soil surface within 1 to 5 days after application without incorporating that nitrogen into the soil. The ammonium from these nitrogen sources is converted to ammonia gas, which escapes to the atmosphere, and you lose that nitrogen. You can expect somewhere between 7 to 33% of that nitrogen, which is about 4% of your total production budget. The second nitrogen loss that could happen, and this is typical in a light textured soil, is that if you have a heavy rainfall and your ammonium has been oxidized to nitrate, that nitrate will leach down beyond the root zone into groundwater, which can have environmental issues. However, if you have a heavy textured soil like the clay, if you have a heavy rainfall, that nitrate is converted to nitrous oxide or other nitrogen gas, which also escapes to the atmosphere. So how can we control ammonia volatilization? When we incorporate that urea into the soil by irrigation, rainfall, or by tillage, ammonia volatilization is negligible. However, we don't have control over the weather, and Tennessee, most of the acreage is no-till. So the option most available is to modify that urea or UAN fertilizer. And this is generally referred to as enhanced efficiency nitrogen fertilizer. Whenever you modify that nitrogen fertilizer, there are two broad classes of enhanced efficiency nitrogen fertilizers. We have the stabilized N fertilizer, and we have the slow release nitrogen fertilizer. The focus will be the stabilized nitrogen fertilizer. There are two main types of stabilized fertilizer depending on the nitrogen stabilizer. And a nitrogen stabilizer basically extends the nitrogen in the nitrogen fertilizer. There are two types. There is the urease inhibitor and there is the nitrification inhibitor. The urease inhibitor basically inhibits the activity of the urease enzyme that helps speeds up the breakdown of the urea molecule or urea fertilizer or the UAN fertilizer. The nitrification inhibitor inhibits the biological oxidation of your ammonium to nitrate. So there are several urease inhibitors. NBPT is the most effective and efficient urease inhibitor across different cropping systems. So how does the NBPT urease inhibitor works? So look at my left hand as the urease enzyme, and it's got exchange sites around where I'm pointing. So what happens is when you apply your urea to the soil, the urea goes to the exchange site of the urease enzyme, and the urease enzyme helps unlock that nitrogen or converts that nitrogen to ammonium. So what happens is when you treat your urea with the urease enzyme, trying to get this gloss here, when you treat your urea with the urease, when you treat your urea with the NBPT, what happens is the NBPT fits into the exchange site and forms a structure which is similar to the urease enzyme urea complex, which inhibits the urease enzyme from breaking the urea until that NBPT degrades for your urea. There are several urease inhibitor products on the market, but it's important to conduct studies to determine which of these products are suitable for the growing conditions in Tennessee. So studies have been done to evaluate this product, and my co-presenter, Dr. Saha, will talk about some unbiased university trials that has been done in Tennessee to evaluate products that work well in Tennessee.
Hello everyone, my name is Debasish Saha. I am an assistant professor at the Biosystems Engineering and Soil Science Department of University of Tennessee, and I will take from this point and I will talk about the research conducted at the university to evaluate different urease inhibitor products in improving corn yield in Tennessee. Researchers at the university have conducted field-scale experiments testing different urease inhibitors product with two different fertilizer formulation, urea and urea ammonium nitrate. Urea is most commonly used fertilizer in Tennessee. The experiments were conducted during 2013 to 2015 in Middle and West Tennessee, including Springfield, Jackson, Milan locations, and different commercial products with different concentration of active ingredient were used. For example, urea was compared with urea plus Nutifafa, which is one of the urease inhibitor products. Then urea plus Adotey containing 20% of the active ingredient, which is the NBPT. And then urea plus Adotey containing 26.7% of the active ingredient. For urea ammonium nitrate, both surface applied and 19 UAN was compared with different brands of Adotey with different active ingredients. For 2014, we only compared the 19 urea ammonium nitrate fertilization with and without Adotey plus. And that is reflected the shaded part in the slide. For urea experiment, we measured ammonia volatilization loss, corn biomass nitrogen uptake, corn yield, and net returns. For UAN, we only measured yield performance. In this slide, you see urea nitrogen uptake by corn at the V6, that is the 6th leaf stage of corn. On your bottom right, you can see that the corn nitrogen uptake at different vegetative and the reproductive stages, which my earlier speaker has explained. The color shaded regions in that graph represents different plant parts taking up nitrogen, such as the yellow part represents the grain nitrogen uptake and all. The V6 stage is very early in the growing season, but nitrogen uptake at the V6 stage is a good indicator of nitrogen availability during the growing season. As the data shows here, that there was no substantial negative impact on corn biomass nitrogen uptake due to urease inhibitor application. Only in my land in 2013, a slight decrease in nitrogen uptake was observed for Nutifafa and Adotey plus treatments. In this slide, we're going to look at the corn yield in response to fertilizer formulation and treatment with the urease inhibitor products. Here you see 2013 yields from my land, Springfield, and 2014 yield from Jackson and Springfield. The dark portion of each bar indicates yield from untreated urea, and the orange portion indicates the yield benefit by using the urease inhibitor products. As you can see here that all the urease inhibitor products provided yield benefits ranging from 5 to 60 bushels of additional corn yield as compared to untreated urea treatment. And Adotey products provided the best yield advantage. However, no yield benefit was observed in 2014 in Springfield Station. This was due to a wet condition closely after nitrogen fertilization, as 12 millimeter of rainfall was received within 3 days of nitrogen fertilizer application. Remember that the urease inhibitor compounds reduces gaseous losses of nitrogen as ammonia from urea when the fertilizer is broadcasted on the soil surface under hot and dry weather. Therefore, wet soil condition in 2014 in Springfield helped the soil to absorb the ammonium released from the urea quickly, and that's why we did not see much effect of the inhibitor product applications. The top panel in this slide shows the 2015 yield from urea fertilization in Jackson and Springfield, and shows similar trend of positive impacts of urease inhibitor products on corn yield. The lower panel shows the grain yield from urea ammonium nitrate fertilizer application in Jackson in 2014 and 2015. In 2014, we only compared UAN 19 that represented by the green bar with or without Adotey plus product. In 2015, Adotey products were applied with UAN for both surface applied and 19 application. As the green bars shows that very little yield benefit was provided by the Adotey product when the UAN was 19, as the fertilizer gets more chance to get absorbed by the soil when you 19 the fertilizer. However, approximately 25 bushels per acre of yield benefit was provided by the Adotey product when mixed with surface applied UAN. Therefore, the producers should consider nitrogen stabilizer products when urea-based nitrogen fertilizer is surface applied, as in case of no-till production under warm and dry weather conditions. In this slide, we will show the economic analysis that we performed from this study. Here you see that the net return from urea plus Adotey product was highest, approximately $500 per acre, which was on average almost $115 per acre higher than the untreated urea treatment. Therefore, careful selection of inhibitor products, fertilizer formulation, application method, and forecasted weather conditions following fertilizer application can provide a positive impact on net economic return. To wrap up, our take-home message for the producers are urease inhibitors perform better when weather and soil conditions are conducive for nitrogen loss as ammonia. Urease inhibitors can increase gain yield. Some inhibitors perform much better than others. That's why you should pay close attention to the concentration of the active ingredient in the formulation. And ultimately, under optimal conditions, urease inhibitors may pay off. We are still continuing studies evaluating newer products, and please reach out to us for any further questions. Thank you very much for your attention.